Welcome to the weird, wet, wonderful world of Western Washington and Puget Sound. Today I am going to be talking about Shine Tidelands State Park and the south end of Hood Head. Shine Tidelands is located at the mouth of the Hood Canal. The Hood Canal is actually a fjord. Canals are man-made passages between two bodies of water. A future video will cover the nearby Portage Canal. The Tidelands experience 16-foot tides. This means the near-shore life has to adapt to extreme changes in water level and the tidal currents. Low tide exposes a plain of sand and gravel. The sediment is covered in varying levels of vegetation. Some areas are mats of soft green seaweed. Here, crockles stand out. Closer to the park's parking lot, shallow tide pools are home to hundreds of teeny crabs. The sparse sea lettuce and eelgrass provides little protection. In the tide pools you can find the remains of crabs, clams, and moon snails. There is also the splashing of teeny sculpin. Moving to the subtidal region, we start with a sandy bottom dotted with sea lettuce, proving tidal zones don't come with marked borders. Here we start seeing fish. At least we see them our way. Sculpin and crab make up the visible life in the extreme shallows. Going a foot deeper, we start to see an unusual fish. These are sole, a type of flounder. These flatfish bury themselves in the sand. The flounder starts life as an egg, from which hatches a symmetrically bilateral fish. The young eat plankton and algae. As they age, one eye moves to the other side of the face, and they start to flatten out. The adult eat mollusks, crustacean, bivalves, and the occasional juvenile flatfish. Can you see the buried sole? He's right here. Their eyes stick up above the sandbed, allowing them to watch for predators. This is probably easier to see. Notice that, in addition to burying themselves, flatfish are camouflaged. Now that you have seen soles hiding, running away, and one exposed, can you spot the sole in this picture? Not to worry, here's his eyes. They are low on the food chain. Flatfish predators include large fish like lingcod, sharks, marine mammals like seals and otters, and birds of prey like the great blue heron, and raptors. Osprey and bald eagles will dive after fish as far as 3 feet below the surface. While I was filming, an osprey was patrolling the shallows. If he caught a fish, he would have to make a getaway. There are eagles waiting in the tree line. Sand and sea lettuce gives way to eelgrass. Eelgrass is a land-descended flowering plant. The distinctive canopy provides an unparalleled habitat for small fish and invertebrates. The thin leaves provide shelter for small animals without blinding them to larger predators. Schools of shiner perch are common. Shiner perch are a species of surf perch. They eat zooplankton. In turn, they are food for ambush predators, such as lingcod. They are also eaten by cormorants and kingfishers. These individuals are juvenile. The adults can grow up to 8 inches long. Unusually for fish, the young are born live. The silver and green stripes make them incredibly hard to track. This adult shiner perch was far calmer, and you can see he's eating zooplankton now the current. The perch is propelled with small flicks of its tail. As you can see, it's an efficient way to move. At the bottom of the eelgrass, we find a fish with a very different form of locomotion. Gunnels make a wave with most of their body. It is not as efficient as what the perch do, carniform. However, they can achieve impressive speeds. When they stop, they look like eelgrass. This individual is a crescent gunnel. This gunnel eats marine worms, isopods, and crustaceans. The thin body can easily slide between rocks. If caught high and dry, the gunnel is able to breathe air. The crescent gunnel can grow to at most 8 inches long, although the majority top out at 4 inches. Males are easily distinguished by orangish spots on the throat, pectoral fins, and belly. In February, females lay a mass of sticky eggs. The eggs may be guarded or left alone. After 2 months, the eggs will hatch. It's late summer, but notice her wide abdomen. Gunnels aren't the only animals to live at the base of the kelp forest. Snails, sea stars, and hermit crabs pick through the seabed, as this green mark hermit crab demonstrates. His microhabitat is referred to as the horizontal substrate assemblage. As we move into the current, eelgrass gives way to seabed. The long, low kelp provides hiding places for larger fish and crabs. An observant snorkeler will find fish resting on top of the kelp. These sculpins are waiting in ambush for small fish and invertebrates. The sheer number of ambush predators is a testament to its effectiveness. It also speaks to the benefits of hiding from predators while you're waiting for dinner. Kelp beds grow like land-bound forests. You can find homogeneous areas. The fields of seabed remind me of fern valleys. The majority of animals live under the thick vegetation. Most of Cheyenne Tideland is a mixed kelp bed. Whereas mixed forests are made of deciduous and coniferous trees, the mixed kelp forest is made of interspersed algae and seagrass. This type of bed provides a diverse microhabitat for smaller algae, filter feeders, snails, more isopods, and of course, fish. Great sculpin are one of the larger fish in the local Campi assemblage. These slow swimmers are ray-fin fish. The great sculpin can live up to 16 years, in the process growing to an impressive 31 inches and weighing over 19 pounds. This little guy was about 10 inches in length. It eats invertebrates and smaller fish. The great sculpin have a limited ability to change skin color. This explains why he blends in so well. He truly did not care about my presence. Looking at this sculpin, it's easy to see the large radial spines that support his fins. This gives away why he is a ray-fin fish. You can also see the large spines protruding from his cheeks. While impressive, his spines lack the venom other ray-fin fish, such as lionfish, are famous for. Great sculpin are not the largest sculpin. That would be the cabezon, or marbled sculpin, who we saw earlier. Cabezon can grow up to 39 inches long. Swimming out to Hood Head, we witness a change in density. At the southern tip, the algae is so thick it obscures the bottom. This canopy assemblage operates as a seafloor for lighter species. Heavier animals, red rock crabs, starfish, and dogwelks, are forced to stay on the sediment. Nudibranchs, isopods, and shrimps wander the pseudo-seafloor. This dock shrimp tops out at about 6 inches long. Dock shrimp, see also Coonstripe shrimp, have translucent bodies. The translucence provides a degree of adaptive camouflage. Octopus and great sculpin have to burn energy to change color. This shrimp just has to walk around. If a predator is not deterred, the shrimp can leap backward with a single stroke of its powerful tail. The predator then has to spot the translucent shrimp again. Dock shrimp primarily eat detritus, dead animals and plants. The eddy at the end of Hood Head condenses detritus from the entire length of the Hood Canal, making this spot an ideal habitat for shrimp. They will eat small invertebrates. Between their incredibly sensitive antennae and their quick reflexes, the dock shrimp are an incredibly hard prey to catch. This is why a great sculpin or a cabezon would just sit and wait for the shrimp to come to them. The rapid opening of their large mouths creates a negative pressure that sucks the food. Humans use nets to catch dock shrimp. Dock shrimp are protrandic hermaphrodites. Most dock shrimp are male during their larval and juvenile stages. After their first spawning, the shrimp undergo a series of molting to transition into females. In addition to changing the gonads, mature females have a brooding chamber where fertilized eggs are stored. A small percent of dock shrimp hatch and remain female. These shrimp live a relatively short life, rarely surpassing 4 years old. I will let this one walk out of frame before we move to our final feature. I want to end this tour with a little botany. The long, wide seabelt is brown algae. The root-like red succulent seaweed is, well, red algae. And the sea lettuce is green algae. The fuzz covering everything is a mix of algae, biomes, and detritus. Did you see the big fish go past? I didn't. I once watched a very lost herring. He was aiming for the seabed, but he got lost in the murk and wound up on the mud flat. He was kelpless.